Hello viewers, you are welcome to InterswitchSPAK Mathematics Prep. My name is Olugona Devi, your mathematics tutor. On this segment, we'll be looking at Introduction to Statistics and Probability. Now to start with, we have statistics. So what is statistics? Statistics is the science of collecting, organizing, analyzing, and interpreting data. And there are two types of statistics. The first one is inferential statistics, which talks about using sample data from the data set and making inferences and conclusions using probability theory. While the second aspect, the type of statistics, is descriptive statistics. It is used to summarize and represent the data in an accurate way using charts, tables, and graphs. So this second type of statistics is what we are going to be working on, because it's the one that deals with analytical approach in statistics, where we can use table, we can use chart, and we can also use data to represent and summarize our given data. So when we talk about descriptive statistics, is the measure used to represent the data set. One, we have the measure of position. Now, under measure of position, then we have two types. One, measure of space, and two, the measure of spread. But let's look at the measure of position, which is the main body of descriptive statistics. When we talk about measure of position, so measure of position is also known as measure of central tendency. And the measure of central tendency, we are talking about averages. And averages is divided into two. We have the mathematical average, then we have the positional average. These are the two types of average that we have, which are the main body of measure of central tendency. And under mathematical average, we have the mean. And under positional average, we have the median and mode. So, and under the mean, we have three types of mean. We have the arithmetic mean, the geometric mean, and we have the harmonic mean. In the course of this lesson, you'll be able to differentiate the three. We have the formula for arithmetic mean, we have formula for geometric mean, and also have formula for harmonic mean. Alright, starting with the mean, we have it here that mean is a point where mass of distribution of data balances. And the calculation of mean is sum of all data points all over the number of data points. So this mean we're discussing here is the arithmetic mean. So the arithmetic mean of any given data or distribution is the sum of all data points over the number of data points under consideration. So we have the median. The median is a point that divides the data into two equal halves, while being less susceptible to outlier compared to mean. So here you can see mean is all data points divided by number of data points, but while median is the middle data, that is halfway of the data. And the data can be in two formats. You have two forms of data. We have one on group data, then we have two grouped data. Now when we talk about ungrouped data is the data where we have a raw data given in the distribution. For example, when you are given the list of numbers like 1, 2, 3, 4, 5, and you have to find the mean. So that list of number is known as ungrouped data. But where grouped data is where you have, when we have a large number to be considered, and those numbers cannot be represented in a table unless they are grouped. For example, if you have to consider number from 1 to 100, now to list 1 to 100 would not be that convenient. So what we have to do is to group this number. We can group them in 5s or group them in 10. When you group in 5, they can have 1 to 5, 6 to 10, 11 to 15, 16 to 20, and so on and so forth. But if you group in 10, we have 1 to 10, 11 to 20, 21 to 30, 31 to 40, and so on and so forth. So these are examples of the form of data. So when we talk about group data, ungrouped data for mode and median. Ungrouped data for median is the middle data point of an ordered data set. Now the ordered data set is talking about the arrangement of the numbers. Before you can find the median of any given number on group data, the first thing you do is to rearrange the numbers. It can be arranged in ascending order or in descending order. You just make sure that that number is in order of magnitude. So after that, you can now look for the middle number. So if that data is odd, if you are given odd data, that is 1, 2, 3, 4, 5 different data, which is odd, so you can easily get the middle. So the middle is the median. But when you are given even data, for example 1, 2, 3, 4, 5, 6, so 6 different data, and 6 is an even number. So to have an even data, so we are going to have two middle number. Two number will fall at the middle. Then what you do is that you find the average of these two numbers. When you add the two numbers together, they divided by 2. So that will give you the median of such number. So that is all about ungrouped data. But why group data? To find the median, you apply the formula as you can see on the screen. So that's the formula for median. And what can we deduce from the formula? In the formula, L represents the lower limit of the median class. That is, before you can calculate the median, here we are going to have a table. And the table will be grouped like 1 to 5, 6 to 10, 11 to 15, or 1 to 10, 11 to 20, 21 to 30. Whichever case you have. So what you need to do first is to look for the median class. How do you find the median class? Get the total frequency divided by 2. So that is that n over 2 you have in the formula. So that's the total frequency divided by 2. That's the median class. When you get the median class, you now go to the class. So the lower class, the numbers are grouped. Let's for example, 6 to 10. Now the lower there is 6. So to find the lower limit, the limit is that you subtract 0.5 from 6. Then to give you 5.5. So the lower limit of class 6 to 10 is 5.5. The lower limit of class 11 to 20 is 10.5 because we are going to subtract 0.5 from 11 to give you 10.5. So that is how you get the lower limit. N is the number of observations. That is the total number under consideration, which is the total frequency. CF, that is cumulative frequency of the class preceding the median class. When you know the median class, then when you add up the frequency before that median class, so the addition of frequency before the median class is what that CF represents. Alright? So F is the frequency of the median class. So that class that we must have gotten by using n over 2 to find the class. So the frequency of that class is our F, where W is a class size. So that class size talking about the group, like from 6 to 10, then we have 5 numbers grouped. From 1 to 10, we have 10 numbers grouped. These are class size of any distribution. Now let's go to mode. Okay, before mode, we have the geometric mean. Don't forget I spoke about arithmetic mean, geometric mean, and harmonic mean. So geometric mean is calculated by when you have two numbers, square root of the product of the two. When you have three numbers, cube root of the product of the three. When you have four numbers, the fourth root of the product of the four, and so on and so forth. That is how you calculate geometric mean. While harmonic mean is calculated by the total number we have. If there are 7 different numbers, that will be 7 over. Now we find the reciprocal of each of the number. That's why we have 1 over x1 plus 1 over x2 plus 1 over x3 to the last number. You add everything together, then you divide the total number by that addition and you simplify. So from there you get the harmonic mean of the data. Now mode. We have it here that mode refers to the data item that occurs most frequently in the given data set. So the number that occurs most frequently in the given data set is known as the mode. And don't forget, I told you, data is divided into two forms. We have the ungrouped. So when you are calculating mode for ungrouped data, you look for the most frequent observation. That is the number that occur most. So number with the most occurrence, that is our mode. But when the data is grouped, just like we have it in median, you use that formula. And the formula, L is still the lower limit of the modal class. How do you get the modal class? You look for the class with the highest frequency. So the class with the highest frequency is our modal class. So when you go to the class, the lower class divided minus 0.5 give us the lower limit. So that's how to find the lower limit for that class. H is a class size, just like we have it W in median. So you just have a change of letter, but it still means the same. So H and W are the same. They represent the class size, also the class interval. The F1 is the frequency of the modal class. F0, frequency of the class preceding the modal class. That is, the class before the modal class is F0, while F1 is the frequency of the class succeeding the modal class. That is, the frequency of the class after the modal class. That is our F2. Now let's now see how do we apply this in simple calculation. The first question is on group data. We have the question as Alex timed 21 people in a sprint race to the nearest second. So we have the value, the time there, 21. Now to find the mean, don't forget that's arithmetic mean. To find the arithmetic mean, they are going to add up all the time given, starting from 51 to 65 to 61, then to 67. You add it up, then divide it by 21 because we have 21 different times there. You divide by 21, and when you do that, your answer will be 61.38095. As you can see on the screen, you can verify it if correct or wrong. And to find the median, don't forget I told you the first is to arrange the number in order of magnitude. So when we arrange this number in ascending order, the least number is 53, followed by 55, followed by 56, 56 again. Then you continue to arrange until we have 70, which is the highest number. And we look, that's 21 numbers. So that 21 numbers, the median will be the 11th number because the 21 is not even data, it's odd data. So 11th, because 21 divided by 2 is 10.5. And when you approximate, you have 11. So 11th number is the median. And when you count from the right, you see the 11th number is 61. When you count from the left, 11th number is 51. So tell you that 61 rather is the median. You can count and verify. And to go to mode, the mode of this data, don't forget, on group data, the mode is the most occurrence number. That is the number that will occur most. And going by this number, the number that will occur most is 62 because it appears 3 times. No number appears more than 3 times there. Other numbers appear less than 3 times. You have 2 and we have 1. So only 62 have the most occurrence. And that is why 62 is the median. Is that understood? Alright, let's now go to group data. Now for group data, look at data. 150 to 154, you can see this is 5. 155 to 159, another 5. 160 to 164, everything is 5, 5, 5, 5, 5. So it's grouped in 5s. So the first thing is to calculate the mean. To calculate the mean of an ungroup data, of a group data, is calculated by summation fx over summation f. We can also use that formula to calculate the mean of group data, on group data, when you have a frequency table. So on group data with frequency table and group data, the mean is calculated by summation fx over summation f. And to find x is the midpoint. We call it mid value of the class. And midpoint of a class is the average of that class. For instance, 150 to 154. To find the mid value, the midpoint, you add 150 to 154. That will be 304. Then divided by 2. That will be 152. So you can see, so 152 is the, you can see there in the other table here. So, and to find the midpoint here, add it together, divided by 2, you get 157. When you do that to all other values in the class, you get our midpoint. And don't forget the frequency was given, so we have the frequency here. They will now multiply the midpoint and the frequency. When you multiply each row, 155 times 5, you have 760. 157 times 2, we have 314, and so on and so forth. You get all these column for fx. Then adding up all the values there, we have 8,530. Don't forget that the sum of frequency is 50. Then to find the mean, then we have summation fx over summation f. So 8,530 divided by 50. So that will give us 170.6 millimeter, because that is the measurement, the unit of the length given. You can verify to get it correctly. So median now, applying the formula, don't forget L1. The first thing, let's look at the median class. What's the median class? N divided by 2. N is 50, then divided by 2. So that will be 25. So now go back to the frequency. This is 5 plus 7. And 5 plus 2, 7, not 25. 7 plus 6, 13, not up to 25. 13 plus 8, 21, not up to 25. 21 plus 9, 30, fine. So we can have our 25 present here. So this is our class. So this lower class, 170, will now subtract 0.5 from this. Then that gives us 169.5. That's where we have the lower limit. You can see lower limit 169.5. Then our n over 2 is this. The cumulative frequency before, that when you add from 5 to 8, when you add all the numbers here, you're going to get 21, because 9 is the frequency of the modal class. So before it, when you add it, it is 21. They can say 9, the frequency of the median class, times the class size, that is the group, from 150 to 154. we have 5 numbers. So that is the class size. And when you simplify this further, you arrive at this answer, 171.7 millimeter. So you can verify the answer as well. So we'll now get to mode. In mode, don't forget, we are going to have the modal class first. The class with the highest frequency. Let's check the frequency down. Down, we are seeing 11 is the highest. So this class is the modal class. So going by this, our lower class will be 175 minus 0.5. That's 174.5. You see there? Then we have the difference between the frequency of the modal class and the one before, and frequency of the modal class and the one after. You see, so we have 11 minus 9, 11 minus 6. So 11 minus 9 will be the numerator, while the denominator will be the sum of the two. 11 minus 9 plus then 11 minus 6. But you simplify times the class size, which is 5. When you simplify this further and solve this, you arrive at 175.9 millimeter. To 1 decimal place anyways, so you can also verify that answer. So we'll now go to measure of dispersion. So measure of dispersion is referred to how the data deviates from the position measure. That is, give an indication of the amount of variation in the process. Another thing is dispersion of the data set can be described by, so to measure dispersion, 1, range. So range is talking about the difference between the highest and the lowest values. That is range. And 2, standard deviation. It is the measurement of average. It is the measurement of average distance between each quantity and mean. That is how data is spread out from mean. So higher the deviation, more the data spread from mean. And to calculate standard deviation, we have to be square root of variance. Why variance is that formula, summation f d square over summation f. D is deviation, and deviation is given as x minus x bar. X bar is mean. So when you subtract the mean from the data, x, which is the midpoint of any data, then you find the deviation d. Alright, so now move to statistics. So in statistics, we say, move to probability. So now we are moving out of statistics, they are moving into probability. Then probability, we say, is a numerical description of how likely an event is to occur, or how likely it is that a proposition is true. So to find probability, probability is just the chance. It's just what is not certain. You have to do it on certainty. So to find probability of an event, we have the number of favorable outcome and the total number of outcome. So that is the probability. Now, for example, some example of probability are 1, tossing of a coin. So when you toss a coin, you have 2 possible outcomes, head or tail. The probability of getting head is 1/2, and probability of getting tail is also 1/2. That is for tossing a coin. Another one is rolling a die or dice. When you roll a die, the possible outcomes are 1, 2, 3, 4, 5, 6. That's possible outcome in a die. When you have 2 dice, then you combine it. 1, 1, 1, 2, 1, 3, 1, 4, and so on and so forth. You get to 6, 6. You see, when you play, if you have been playing a game called Ludo, if you have played it before, then you understand what I'm really talking about. You know, when you roll the die, when you just roll it and you look, you can give you any 2 numbers. It can be 1, 1. It can be 2, 5. It can be 3, 4. It can be 6, 6. So any number. So all these are outcomes of 2 dice. And the total outcome of 2 dice is 36. But while the total outcome of 1 die is 6. And the probability of each of the outcome in a die is 1/6. Then we have terminology in probability. 1. The process by which an outcome is obtained. That's experiment. That's 1. 2. Sample space. The set of all possible outcomes of an experiment. That's sample space. We have event. Any subset of a sample space is called event. Examples are given. We have outcomes, which is the result of a single trial. That's outcome. We have equally likely outcomes. That is, 2 outcomes of a random experiment are said to be equally likely if, upon performing the experiment a large number of times, the relative occurrence of the 2 outcomes turn out to be equal. That is, equally likely outcomes. Then we have trial. Trial means performing a random experiment. So that is all about terminologies. We also have events in probability. 1. Simple event. If the event has only single element of a sample space, that is, if there is only one element in the event, so that event is called the simple event. We have compound event, which is the opposite of simple, when we have more elements, 2 or more. So that is where we call that event a compound event. We have independent event and dependent event. Now, if the occurrence of any event is completely unaffected by the occurrence of any other, such events are independent. You see that? And we have dependent, which is the opposite. The events which are affected by other events. That is dependent. We have exhaustive events. That is when you exhaust all the elements. That is when you are given 2 or more events, and that 2 or more events contain everything that is in sample space. It means that you've exhausted the sample space. So that kind of event is known as exhaustive event. Then we have mutually exclusive event. If the occurrence of one event excludes the occurrence of another event, then the event is, that is, no 2 events can occur simultaneously. So that event is called mutually exclusive. So now go to addition theorem in probability. That's when you have 2 events that are mutually exclusive. So to find the addition formula of this is that P, the probability of A union B, gives us probability of A plus probability of B. That P means probability. So union is the addition. So, and that is the formula. And we also have theorem 2 there. Theorem 1 talk about mutually exclusive. Theorem 2 talk about when they are not mutually exclusive. That is, the probability of A union B with probability of A plus probability of B minus probability of A intersection B. Let's say, for example, if you have 2 events like odd number and even number. So odd number and even number are mutually exclusive. But we have even number and prime number, or odd number and prime number. You see, some odd numbers are prime numbers, like 3, 5, 7. They are odd numbers, they are also prime numbers. You can see, so they are not mutually exclusive. So to find that kind of probability, they must include what is common to them. If you notice intersection, don't forget that we have learned that in set under number and numeration. So this intersection means what is common. So what is common to odd and prime? We bring them out, then you subtract it from the probability of odd plus the probability of prime, and that will give us the answer. This is theorem 2. Then we have multiplication theorem. That is, if A and B are 2 independent events, then the probability that both will occur is equal to the product of their individual probabilities. So then we have probability of A and B, that is intersection, to the probability of A times probability of B. Example is given here, that when you have the probability of appointing a lecturer who is BCom, MBA, and PhD with probability 1/20, 1/25, 1/40 is given by, you see, since it's independent, you just multiply their probabilities, and that will give us the answer. Then we'll now go to permutations and combination. That's another aspect of statistics, and here we have the 2. Now the 2 have to do with 1, that's with number of ways. Where 1 permutation deals with arrangement, you can see permutation is number of ways to arrange things, and combination is the number of ways to choose things. So in permutation you arrange, in combination you choose. And also in permutation, order matters. The order, we can have AB, we can have BA. It's not the same order, so it matters. But why in combination order does not matter? If you have AB, you can't repeat again. So AB and BA, they are the same. So you can't repeat combination. So that is what it's talking about. Another one is that these are for list. In permutation, you list. While in combination is for group. You group them by bringing them together. So that is that. Now let's look at the formula for combination. So in combination, if you have n combination r, so n combination r is given as n factorial over n minus r factorial. You can see that? That is the formula for combination. Why factorial? Factorial means the product of the number when reduced to 1. For example, if you have 4 factorials, reduce 4 to 1. To reduce 4 to 1, you have 4, 3, 2, 1. Then you now multiply everything. That will be 4 times 3 times 2 times 1. That is 4 factorial. So the formula for combination is this. Look, for example, how many pairs can be made from a group of 6 people? You know, pair is 2. Pair is 2. So that means that we have 6 combination 2. So using the formula, 6 factorial over 2 factorial into bracket 6 minus 2 factorial. So 6 factorial is 6 times 5 times 4 times 3 times 2 times 1 to give us 120. Then 6 minus 2 is 4. So 4 factorial is 24, while 2 factorial is 2. When you simplify, you get 15. And in permutation is, if you have n permutation r, is n factorial over n minus r factorial, then r factorial. So from there, we have that. And when you combine, so see people are in a contest. How many ways can first and second place be awarded? So you have to arrange them, first and second. So to do that, you do it in 6 permutation 2 ways. When you simplify using the formula, you see that the answer will be 30. So now let's now look at exercises. Exercises on statistics and probability. So number 1, what is the average of the numbers 2, 5, 6, 10, 10, 12, 13, 15, 17? You see that? Average is just the addition. Add it divided by the number. So you can see the solution here. When you add, you divide, the answer will be 10. That is that. So the next one, find the variance. Find the variance of the number 4, 6, 5, 7, 8. Variance is the formula given there. That's formula for variance. Then the first is to find the mean. Mean, that's what you look for the first question. That's to add up all the numbers divided by 5. Then we have 6 as the mean. Then subtract the mean from each data, then square and divide the sum by 5. Then you see your answer will be 2. So that is the variance. All right. So the next question, you have to find the standard deviation. Standard deviation of this set of numbers 2, 3, 5, 8, 11, 13. Just like we have solved variance, standard deviation is square root of variance. So we first of all find the mean, then we find the mean, calculated mean, as you can see on the screen. So mean is 7. Then from there you subtract each data minus 7. So subtract 7 from each data. So you square them, add it up, divide by the total number, which is 6. And from there, you arrive at square root of 96 over 6. And you divide it, it will be 49 over 3. Then you find square root of 49, 7. So 7 over root 3. And this root 3, don't forget, in normal numeration, we talk about this, which is solid. So solid cannot be the denominator of any given fraction. Then you have to rationalize. So by rationalizing this, we have 7 root 3 over 3 as our answer. The next question. So we have to evaluate 10 combination 7. 10 combination 7. Don't forget the formula. N combination R is n factorial over n minus r factorial. When you substitute, you have this. Then when you reduce this 10 to 7, you can reduce 10 to 7 factorial by having 10 times 9 times 8 times 7 factorial over 3 factorial is 3 times 2 times 1. While 7 factorial will take care of 7 factorial. Then 2 in 8, 4. 3 in 9, 3. When you have 3 times 4 times 10, that's 120. So 120 is the answer. And the next one is to find the median. Don't forget median. You have to rearrange first. When you rearrange, you have this data. So since there are 7 data, so the fourth number will be the median. The fourth position, when you divide with 3.5 approximately 4, so the fourth position is the median, which is 26. Then we have to find mode here. Mode is the most occurrence number. If you check the number, you don't need to rearrange mode. Just check which number occur most. You see it is 19. So 19 have the most occurrence state. That is mode. Then we are given that, okay, sorry. We are given that in a class of 10 students, the score in mathematics test are as follows: 5, 7, 5, 3, 5, 7, 4, 6, 2, 5, 4, 9. What is the range of the distribution? So to find the range, don't forget, range is highest number minus lowest number. So the highest number there is 9, lowest number is 2. When you subtract, you have 7. So 7 is the range. Alright, the next question, what is the mean of the first 101 natural numbers? Now, the first is to know, how do you find the first 101 natural numbers? You apply this formula to find the sum of the first 101 natural number. And to find it, we get this. So to find the mean, it's just to divide this product by 101. And when you divide it, then we have 51 as the answer. You can try that. Just look at, make sure you look at the formula. The formula is derived from AP, sum of AP. You can use that to derive this formula, to have the sum of the first n natural numbers. So that is that. Then the next question is, what will be the value of the probability of not E? Probability of E is 0.012. Now what we need to know is that the probability of E plus the probability of not E is equal to 1. So to find the probability of not E, just make it on your formula. You have 0.012 plus the probability of not E equals 1. Then take this to the other side. It is a positive value turned to negative. So probability of not E will be 1 minus 0.012, which is 0.988. And that's probability of not E. Now the next question, find the probability that the sum of 10 will appear in 2/3 of a fair die. Now, that's when you throw 2 dice once or one die twice, the outcomes is what you're able to see here. This is the first die, this is second die. So about the addition of the two, so 1 plus 1 is 2, 1 plus 2 is 3, 1 plus 3 is 4, 1 plus 4 is 5, 1 plus 5 is 6, and 1 plus 6 is 7. Down to 6. Then we have all the addition there. So probably that 10 will appear. So now look at where you have 10. So we have 10 here, 1, 10, 2, 10, 3. So we can only have 10 in 3 places out of 36. So the probability of sum of 10 would now be 3 over 36, which is reduced to 1 over 12. Okay, let's look at another question. In a bag contain 4 red, 8 green, and 6 blue balls of identical size. The probability that a ball selected randomly is either red or green is, you see, we have to get the list. R for red, G for green, and B for blue. Sorry, B for blue. Now the probability of red is 4, probability of green 8, probability of blue, let's take this one to a B, so let's correct that, B is 6. Then the total number is 18. Now the probability of R or G, that is red or green, is probability of red plus probability of green. So probability of red, that will be number of red over total number, and probability of green, number of green over total number. When you solve the fraction, you have 12 over 18, and when reduced to the lowest term, it will be 2 over 3. Alright? The next question. The probability of obtaining a prime number in a single toss of a fair die is... Now, when you throw a die, don't forget, the outcome is 1 to 6. We have, you can say 1, 2, 3, 4, 5, 6, that's 6 numbers. And prime number here are 2, 3, and 5. That's 3 numbers. So the probability of prime will now be 3 over 6. That will give us 1 over 2 when reduced to the lowest term. The next one is dash is a list of all possible outcomes of an experiment. You know, we have discussed that under the terminology in probability. So the list of all possible outcomes of an experiment is called sample space. You can see the list of all possible outcomes of an experiment is called sample space. So sample space is the formula. So you go back and learn other terminology so that you can get it in case you are asked any question on that. So we have the probability that a number selected at random from 1 to 45 is a multiple of 4 is, now to find the probability of getting multiple of 7 rather, multiple of 7. So the first is that we have number 1 to 47, 1 to 47, 1 to 45. Then we have 45 numbers, and the event E1 represents the multiple of 7. So you have to list out multiple of 7, which are 7, 14, 21, 28, 35, 41, 42. Then to find the probability of multiple of 7 is the number of elements in multiple of 7 divided by total number of elements. So under consideration. So now in multiple of 7 we have just 6 elements. Then the total is 45. So we have 6 over 45. When reduced to the lowest term, you have 2 over 15 as the answer. Now, we are given that if the mean and median of a certain distribution are 6 and 9 respectively, its median will be... Now, this aspect is talking about the formula called Carl Pearson's formula. So take note of this formula. Carl Pearson's formula says that mean minus mode is equal to 3 into bracket mean minus median. Just substitute. You can be asked to find any of this. Either you can be asked to find mean, you can be asked to find mode, where you'll be given 2. Just take note of the formula. So when we substitute our value, mean is 6, mode is 9. Then 3 into bracket mean is 6 minus median. By opening bracket, 6 times 3 is 18, and 3 times median is 3 median. Why 6 minus 9 is minus 3? Collecting like terms, taking everything here, 3 minus 3 median to the left hand side, we have 3 median. Bringing minus 3 to the right hand side, we have plus 3. Adding it together, 21, divide both sides by 3, then the median will be 7. So that is the median, 7. Then we have this question. Given that P is a number from 1 to 12, what is the probability of selecting a prime number from the set? You see, first get 1 to 12. There are 12 numbers, and let's pick out the prime numbers there. These are 2, 3, 5, 7, 11. So we have 5 prime numbers from 1 to 12. So the probability of prime will now be 5 over 12. So that is the probability. What is the median of this set? Don't forget, rearrange. When we rearrange them, you see that here we have 12 data, which is even. So the even data will leave 2 numbers at the middle. So the 2 numbers at the middle are 11 and 13. You now find the average. Don't forget, I've explained that. You find the average, you add 13 and 11, then divide the result by 2. So that will give us 12. So 12 is the median. Now we have this question that there are 8 green balls, 4 blue balls, and 3 white balls in a box. Then 1 green and 1 blue balls are taken from the box and put away. So initially we have 8 green, 4 blue, and 3 white. So 1 green and 1 blue is taken away. So now leave 7 green, 3 blue, and 3 white. So now the total number of blue balls will be 13. So the probability of selecting a blue ball, so when you select blue, blue is 3. So 3 over the total, 13. So that is the probability of blue. Now, we have here in a soccer competition in one season, a club has scored the following goals. You see, the mean, median, and mode respectively are. Now, first, to find the median, the mean. To find the mean, you add up all the numbers divided by, if you count, you have 20 different goals. 20. So add it all divided by 20. The total is 36 divided by 20. That's 1.8. That is the mean. The median, you will rearrange. When you rearrange this number, you see there are 20 numbers. So that is even. So 2 numbers will be at the middle. That's 1 and 2. So 1 and 2 fall at the middle. Then find the average of 1 and 2. By adding together and divide by 2, they have 1.5. And mode is the most occurrence number. That is 1. 1 appears 6 times. 6 times. So that's the highest occurrence. So the mode is 1. So we now arrange it accordingly. So mean is 1.8, median is 1.5, and mode is 1. So we have 1.8, 1.5, and 1. Now the next question. In a school, there are 35 students in class 2A and 40 students in class 2B. The mean score for class 2A in a mathematics examination is 60.00, and that for 2B in the paper is 52.50. Find, to one place of decimal, the mean of the combined classes. Now the first thing is that we find the total mark for each class. Now the mean of 35 students is 60. The total mark will be 35 times 60, and that's 2,100. And the mean for class 2B, there are 40 students, and the mean is 52.50. Then the total score, the total mark, will be 40 times 52.50, and that will give us 21. Then the grand total, the total of the 2 classes, is 4,200. Now, to find the mean of the combined classes, then we have 4,200 over the total number. That is the number of pupils in class 2A and the number of pupils in class 2B. So we add them together to give us 75. Divide 4,200 by 75, you have 56. So 56.00 is the mean of the combined classes. All right. Another question. We have a bag contain 3 apples, 4 oranges, and 3 bananas. So we have here number of apple, number of orange, number of banana. What's the probability of selecting a banana and then an apple? So when you pick a banana, you know, probability of banana is 3/10. So when you pick a banana, then you pick apple. Going back to pick apple, the number of fruits will have reduced. Initially, we have total number of 10 fruits. So when you pick one banana, banana will remain 2. Then we are now going to have 9 fruits left in the bag. So to now pick apple, apple will now be 3/9. So when you reduce this, it will have it 1/10 as the answer. Do you understand that? All right. So the next question is, we have it there that the chances of 3 independent events X, Y, Z occurring are 1/2, 2/3, and 1/4 respectively. So probability of X is 1/2, probability of Y 2/3, probability of Z 1/4. Then what are the chances of Y and Z only occurring? So that means if Y and Z will only occur, it means that X will not occur. So probability of not X will now be 1 minus probability of X. So 1 minus 1/2 is also 1/2. So that's why we have 1/2 here. So the probability of Y and X, Y and Z only, will be probability of Y times probability of Z times probability of not X. When you multiply everything and reduce to lowest term, it gives 1/12. So 1/12 is the probability. The next question here, we have it that how many ways can a committee of 3 women and 4 men be chosen from 6 men and 5 women? Now, 1, the total number, we have 6 men, 5 women. The number of selection, we want to select 4 men and 3 women. To select 4 men from 3 women is 4 men from 6 men is 6 combination 4, and to select 3 women from 5 women is 5 combination 3. So the total selection will be 6 combination 4 times 5 combination 3. And when you apply the formula, don't forget the formula of combination, when you apply it, they will reduce, and arrive at 150 ways. So 150 ways is the number of ways. Now, the next question. In how many ways can the letter of the word mathematics be arranged? Now, we have mathematics. This is an aspect of permutation called permutation of indistinguishable objects. There's an object you cannot distinguish, like AA, MM, TT. You cannot distinguish, so you have to know the number of times they appear. So A appear 2 times, M appear 2 times, T appear 2 times. We take note of it. Why the total number of letters here? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 letters. To find the total number of arrangements, we're now give us 11 factorial over then the letters that appear more than 1. So that is 2 factorial, 2 factorial, 2 factorial. When you simplify this now and reduce it to the lowest term, you are going to have 4,998,600 ways. So you can multiply it and verify your answer. And the last question for this segment is to evaluate 8 permutation 5. 8 permutation 5. Don't forget the formula for permutation. we have n factorial over n minus r factorial. When you substitute your value, so we have 8 factorial over 8 minus 5 factorial, then that will give us 8 factorial over 3 factorial. When you reduce this, the 8 factorial to 3 factorial, we have this, then 3 factorial. 3 factorial will cancel 3 factorial, then 8 times 5 times 6 times 8 times 7 times 6 times 5 times 4 will give us 6,720. So that is the value. So you can verify that. So with this, we have come to the end of our lesson under statistics and probability. So I want to say thank you to every one of you for your time. Thank you so much. So I really appreciate that, and I really hope you enjoy your time over this lesson. So I will still advise everyone to go back, pick your textbooks, pick some other materials, and work on some questions regarding this lesson. Until we meet again, I say bye for now.